Welcome, everyone, and thank you for joining our webinar with the Chan Zuckerberg Initiative discussing Meta Knowledge Graph. My name is Marilee Parsons, and I'm part of the webinar team here at Neo4j, and I will be your host for today's event. We are so excited to have you all here with us today. A couple of housekeeping items before we get started. We invite you to submit any questions you have throughout the presentation using the Q&A tab located at the top of your screen. We'll hold off on Q&A until the end of the webinar, and we'll answer as many questions as we can within our time frame. The webinar is being recorded, and the on-demand version will be made available within 48 hours. With that, I'll go ahead and hand it over to Alicia Frame, Senior Data Scientist at Neo4j. Alicia?
Thanks. So one of the coolest things about my job is seeing all of the awesome stuff people build using Neo4j. And so I'm really excited today to be hosting this webinar with Kunal Patel and Ziyang Liu from the Chan Zuckerberg Initiative to talk about the Meta Knowledge Graph, which is a tool to help connect scientific articles and preprints and build a live map of science so that researchers can follow developments, intersections, and emerging trends and find new papers and concepts that they might not have been looking for. So today we have Kunal, who's the engineering lead at the Chan Zuckerberg Foundation, as well as Ziyang Liu, who's the data engineer working on Meta. And they're gonna give a high-level overview and then move into a hands-on demo and talk about what knowledge graphs are useful for, and then get into the technical implementation. And then we'll get to spend the last 20 minutes on an interactive Q&A. So please enter your questions in the Q&A box, and I'm super excited to have this discussion. So over to you, Kunal.
Thank you, Alicia. Hello, everyone. I'm Kunal Patel. I'm working with CZI as Senior Engineering Leader. I've spent most part of my career solving real-world problems in life science using technology. I'm part of CZI's Science Initiative, where we work on some of the high-impact projects and initiatives. One of those is Meta. Today, we are going to walk you through the details of our robust and scalable knowledge graph that we have built as part of Meta platform. But before we do that, we want to introduce Meta to all of you. We have a short video that will play now, and then following that, we'll do the demo of the actual web application.
Every day in biomedicine, 4,000 scientific papers are published. That's one paper every 20 seconds. As the research continues to grow, so do the amount of hours it takes for researchers to draw the right insights that, when discovered, will lead to new collaborations, accelerate new breakthroughs, or even bring us to a faster cure. But only if this knowledge is connected and easy to explore. That's where Meta comes in. Meta is a free research discovery tool that helps researchers understand and explore science as it evolves in real time. Meta uses machine learning to analyze and map millions of research papers, like articles and preprints. Meta uses this technology to create automated feeds tailored to your unique research interests. You can track new developments, browse related research, discover emerging scientific trends you may not have known to search for. So you will never miss an insight. It can change everything. Science moves fast. Now you can see where it's going. Get your free account at meta.org.
Thank you. Let's see the demo. So as you learned, Meta is a discovery tool for biomedical research designed to help researchers to stay up to date with new research. And we are using technologies like machine learning to go deeper and organizing new scientific knowledge as soon as it is published. So let me just log in and show you a quick demo. All right, let's start with the Discover feature. So we have pre-created feeds to quickly onboard researchers and users, those who have not customized feeds to their interest, for general exploration purpose. This is something that we feel would be an interesting topic or trending feed, and we publish in this Discover section here. You can add as many feeds as you would like to take different facet of research area and avoid having too much noise by creating one feed that is very broad. So this is what you see on screen is something that is created by underneath platform. Let's say you want to follow, you find any one of these feed very interesting, you want to follow that. You can simply click on follow and it will appear in your feed library where you can click and you can see the feed. You can slice and dice by day, week, month, and see how many papers are published for this particular feed. You can use filter. You can say, I just want to say preprints, and you can see only preprints, things like that. So this is about pre-curated feeds that is generated, auto-generated by the system. But let's say you're interested in some of the very specific research area, you can create your own feed. So let me just, right. I'm creating my own feed and I just say start feed. As soon as I start feed, I can see the feed again in my feeds menu. And from here, I can edit my feed, I can share my feed, I can delete my feed, I can play around with feed. At Meta, we want to make sure that researchers get an opportunity to create their own feed and review that versus relying upon their capability to search across millions of scientific publication to get the relevant result. So let's click on any one of the feed. I'll show one last feature. Let's say we are interested in this particular paper. Click on that. And this is our paper lender where you can see the paper. You can, if there are any citations, you can see this, references. You can see that which are the other similar papers that are related to this paper that you see here. And then the key topics. You can go there and you can explore, you can follow this feed as well. So all the information that you see on the screen, it is all coming from underneath knowledge graph platform where we have connected concepts, entities, and that's how we are bringing information on screen. So with this, we will jump right into the details of the knowledge graph, which is the backbone of this application. All right, so why knowledge graph? The information that you saw on Meta application that had papers, that had preprints, that had author and different entities. So something like this needs underneath a data structure which allows traversing through different entities seamlessly. And for that reason, we have created this biomedical knowledge graph. This knowledge graph consists of 5 core entities: authors, papers, journals, institutions, and concepts. Our goal is to ensure that biomedical research community get to traverse through this information as needed, so they can discover deep relations between entities without knowing underneath structure. The knowledge graph that we have today has 30 million papers from PubMed and bioRxiv, 39,000 journals, 20 million authors, 430,000 affiliations, 19 million biomedical concepts. And this knowledge graph continues to grow at a pace of over 4,000 new papers every single day. So this is about the high level information on what is biomedical knowledge graph of Meta. I'll have my colleague Ziyang walk us through that, how we have built this knowledge graph of Meta.
Hi, my name is Ziyang. I'm one of the data engineers behind the building of the Meta knowledge graph. I'll talk about the challenges of building this knowledge graph, how a graphical database helped us navigating these issues, and what role Neo4j plays in our roadmap. To start with, when looking at the technical aspect of building such a knowledge graph, we unavoidably started looking at a few constraints from using other alternatives to host our data. Because of the complexity and unpredictability of the real world, we would need to be upfront flexible when designing the shape of the knowledge graph. As an example, imagine you would get some new interesting information from a different source that you just never seen before. Say you get Ziyang's name in Chinese spelling, but due to existing RDBMS schema design already in place, you would need to go through the entire pipeline to make inevitable migration to be able to incorporate new content. While on the contrary, if you host the data in a NoSQL database, you would lose the carefully constructed relations between entities and you would have a very loose coupling. This can cause confusion down the line, especially when the connections get more and more complicated. Another thing to keep in mind is the performance. Operating at a massive scale took away a lot of flexibility options that would otherwise be available, like manual operations or custom scripts. However, operating at a scale of millions of documents, all of those hacks will only increase your technical debt. And there will be one Friday evening, after you get home, you're ready to spend time with your family or enjoy your party, and then the system goes down and demand you pay the debt plus the interest. We certainly don't want to see that happen. The slow performance also hurt developing and debugging cycles. Imagine how much time developing would cost if a developer has to wait 3 days for each service iteration just to find some Unicode conversion issue that only exists in real world, but not in your example test set. These are just natures of big data, and we need to be able to work with it and still iterate fast and ready to repivot at all times. And that's a performance constraint we need to think about. At last, we need to be considerate about integrations regarding ecosystems and frameworks. If there's an ever so perfect data engine that is crazily fast, but only read and write to Google spreadsheet, that would not work. Because you need to design your whole system around Google spreadsheet, and that is not realistic. We want to leverage the Spark and Spring ecosystem that is built and proven by the industry, so we don't end up spending all the time writing connectors instead of business logics. Regarding to the roadmap, now that we have outgrown what RDBMS can offer, we are moving towards a graphical database in order to keep up with the complicated world. We started migrating our flexibility-sensitive services, what we call the enrichment processes, to leverage Neo4j's flexible schema. In the meantime, we started exploring features from Neo4j to build on top of the built-in graph queries. We also integrated with a server plugin to open up access to and from the graph by designing APIs that are abstract across our system directly on top of Neo4j's own server to allow optimal performance and minimize the number of necessary components and layers in our technical stack. We plan to use more and more graphical features to leverage the nature of our connected dataset. We're in transition to run machine learning algorithm more efficiently by pulling a subgraph consisting of different types but related entities to a big data compute engine like Spark to fully distribute the computations and eventually be able to horizontally scale the operations. Here's a simplified abstracted view of the concept or paper to concept aspect of our system. The background is that we import thousands of papers every day. Each of them is then enhanced with machine learning algorithm to find the concept they're referring to. Starting off the top left corner, it is a process that enriches the concept information. This process finds things like Wikipedia link or new definitions for a concept, whatever might be interesting regarding our concept. At the bottom, that is our concept recognition that finds what concepts are mentioned in the paper. These mentions are later used by the top right process, the recommendation generation, to figure out if we should consider correlating two papers because they mention the same concept, they should recommend each other. Each component is flexible enough to update or utilize information from the database without having to interfere with each other on the schema level. And eventually, we can create more insight after visualizing the data by connecting a knowledge graph with machine learning algorithm and mining pipelines. We can directly see what is going on in the real world. It opens up the 0 to 1 possibility of exploration. We're capable to do analysis on the right, which was not possible having the data sitting in the data warehouse, collecting dust and accumulating errors. Coincidentally, this echoes with the core value of MET as well. we emphasize on the power of connection and exploration. These data and pipelines eventually paint a picture for the knowledge graph team to learn new insights and allow us to pivot and focus. Meanwhile, the insight from a product would then naturally allow users to keep track of the research they're interested at, or which are traditionally scattered and otherwise extremely hard to manage effectively, if not impossible at all in the modern days. Today, the meta-knowledge graph combines many external data sources, and we compute new relationships between them into a single data layer that serves one application, the meta application. This knowledge graph is a single source of truth for all the data elements for the meta web app that you just saw. And Kunal will talk about the future roadmap and other scenario that is being considered or developed.
Thank you, Ziyang. So as Ziyang mentioned, we work with PubMed and bioRxiv to onboard scientific content, and we run about 19 to 20 data services every single day, which has combination of traditional data processing and also embedded machine learning into pipelines to create features like disambiguation, generating auto feeds and things like that. Using all of those technologies and using Neo4j, we have today stand up this knowledge graph, which is connecting different entities and which is being used by our own meta web application. So this is a good beginning. We are trying to solve a problem, which is what Ziyang mentioned, flexibility, performance, and stability, is how do we rely upon this data structure, which is the backbone of entire application. Now, how are we planning to enrich this whole platform, and what are our goals, and what are our thoughts on this? So let's just take a look at that. So if you see, we are thinking about having more than one tenant. As we see, there are a lot of use cases applicable on similar information that we are hosting on this knowledge graph. First and foremost, we want to work with more sources. We want to onboard more content. That means more information, more enrichment, more connections, and more insights available in this knowledge graph. Now, using that, we want to enable another different use cases on top of this knowledge graph. Things like, how do we go deep into one particular area, and for example, rare disease, and create something like Meta for patients, which is targeting some of the rare disease, tracking very specific development in very specific area versus opening up application for everything. And many such more use cases are applicable on top of this knowledge graph. Also in future, opening up access for researchers to work with this kind of structure directly along with Meta web application. So we believe that using NLP and machine learning, which are very critical areas in our core, scalable and open approach will also depend on collecting and linking accurate data about the varied components and outputs. This means that we are creating new means of discovery, and we are helping to foster reproducibility by ensuring that research findings are linked to specific reagents, protocols, and data generated. And if we do that, we can expose contradictory findings, discover new avenues of research, examine the impact of funding, and we can serve many other use cases and research community. In the future, we want to ensure that a broad and distributed effort to represent the sum of all biomedical research has the potential to unlock a much greater number of exploratory, informational, and analytical use cases, and provide key piece of open infrastructure that can become backbone of a global biomedical data commons. In essence, it has started with one application, and our goal is to enrich this and make it like a backbone of a global biomedical data commons. And for us, this is not just a knowledge graph. This is a graph for goodness.
I think we're just about at our time for today. Colonel, can you advance that slide for me? So if there are additional questions that you might have, you can send them to us at webinar@neotechnology.com. Also visit meta.org and sign up. I believe, as Colonel said, they are in the beta testing of that. Is that correct, Colonel?
Yeah, we are in open beta. Yeah.
Excellent. I know that there were also several questions about the webinar being recorded, and yes, it was being recorded. So check your inboxes within the next day or so, and you'll see something from us with a link to the recording. And just thank you so much to the Chan Zuckerberg Initiative team for being here. It was such a fascinating presentation on what you guys are doing. So I just want to thank everyone for joining us today, and have a good one. Be safe out there and have a great day.
Thank you, everyone.
Thank you.
Thank you.